This is Precalculus Chapters 1 and Chapters 1 and 2. Review. There's some questions on the board. We're going to start on page 95 with 2.2. Number 27. It says solve the equation by completing the square. So 27, I'm going to write x instead of w. I don't know, all right, so it's x squared minus x minus 1 equals 0. All right, what's the first step? Move the 1 to the other side. Move the constant to the other side. So we have x squared minus x. So we're adding 1 to both sides. Because we're solving. We're not completing the square to graph. If we were completing the square to graph, we'd leave the 1 on the other side. But that's not what we're doing. We're trying to solve. Now we take half of b and we square it. So b is negative 1. So that's positive 1/4. So I'm going to add 1/4 to both sides. My binomial squared is x minus half or plus half of b, whatever half of b is. Half of b goes right here. And that's our term squared. 1 and 1/4 is 5/4. Yes, take the square root of both sides. On my left-hand side, I'm left with minus x minus 1/2. Plus and minus square root of 5, I'm going to unsquare 4 and make that 2. So, the square root of 5/4 is the same thing as the square root of 5 over the square root of 4. So I unsquared the 4. Now I'll add 1/2. X is 1/2 plus and minus the square root of 5 halves. All right, so you will need to know how to complete the square. All right, on the next page, number 65. Is 2, again, I'm going to make it x. It's y in your book. X to the 4th minus 9x squared plus 4 equals 0. So when we have terms, the 4th, the 2nd, and a constant. This was number 27. When I video, I should always write the problem number by it. Makes it easier for y'all to go back and see it. All right, I'm going to make u equal to x squared when we have a 4th, a 2nd, and a constant. So it looks like a quadratic. So this becomes 2u squared minus 9u plus 4 equals 0. So I'm using this substitution to make it look like a quadratic. Then I go back and put x squared back in for u. Does everybody understand how I get u squared?
I feel like
we did it in class. So it would be 2 x squared equals 2x to the 4th. Get it? So for x squared, I'm just going to substitute u in, and it becomes that. What did I say? Why do we do this? It makes it look like a quadratic. So then once we solve for u, we go back in and put x squared.
Will you always use the substitution u equals x squared?
Always. And we're going to do that when we get to trig as well. We're gonna substitute U.
So is this not the way you can multiply A and
Yes, A times B, which is 8, such that we add them, the result is -9. And what is that?
-8 and
-1 and -8. We put it over to U. And we simplify. So that's 2U minus 1 times U.
I'm trying to get 8. I thought it was 4.
No. The product of A times C, such that we add them and the result is 9. So, if I multiply -1 times -8, I get +8. If I add -1 and -8, I get -9. But remember, this is the little trick, right? We then put it under the first term and simplify. All right, but what is U? It is x squared. So now I'm going to go back in. I'm going to set each of them equal to 0. And I substituted x squared back in for U. Now I'm going to solve for x. So I'm going to add the 1. 2x squared equals 1. Divide by 2. Take the square root. X is plus and minus 1 over the square root of 2. Because the square root of 1 is 1.
So we just wait. Okay, I did that.
Yes, good. Okay,
Miss Haley?
yes,
So for the test, remember?
yes.
I did this problem like completely different. I just graphed it and found the x-intercept. Do you want me to do this?
I probably will tell you, if I tell you solve by factoring, then this is what I'm looking for. If I give you no information on how to solve it, then you solve it however you want to. Yes?
When we use it, when we do the graphing thing, the numbers that we like are using, are those the zeros?
Those are the zeros.
So we put like plus minus. Well, yeah, for this.
You're gonna, if you graph it, you're gonna find all 4. And it's gonna be in decimal form. It's not gonna be 1, okay. So now we're gonna add 4. And when we take the square root, x is plus and minus 2. So there's our 4 solutions. All right, so that's 2.2.
In what cases when we have a radical would we not do plus minus?
The only time you're not going to take a negative of a radical is if it's the length of a side of a triangle, the length of a box. Time can't be negative. Something in real life, a real life application of this that's not going to be negative. All right, everybody good with those so far? 2.3, we're on page 105. And it's number 11. All right, so 2.3, number 11. I think there was one similar in your book. All right, I'm going to read. A radiator contains 10 quarts of fluid, 30% of which is antifreeze. How much fluid should be drained? All right, so we have 10 quarts, and it is
Is this 11 or
12. Didn't you say? Oh, 11. 11. It's the same. 8 quarts. I kept saying, wait just a minute. All right. trying to erase this. Now this eraser is actually working better. Okay. 11. Let's do 11. I'm going to keep my eyes on 11. 8 quarts. Said 8 quarts, not 10. This is number 11 of 2.3. 8 quarts, which is antifreeze, 40%. How much fluid should be drained and replaced with pure antifreeze so that the new mixture, we want to end up, so we're going to drain off 100% antifreeze, some amount, so that we end up, and we're going to add rather. So initially we're going to have 8, but we're going to drain some off, and then we're going to end up with, what is it? Antifreeze 60. All right?
This reminds me about door.
It does. All right. So are we really going to start with 8?
Wait, can you explain the equation one more time?
Yeah, okay. We're going to begin with 8 quarts of an antifreeze that's 40%. We're going to take some of that off. We don't know how much we're going to take off. So we're going to have 8 quarts. We're taking some off, but that is 40% antifreeze. Got it? What are we going to add? How much 100% antifreeze? Whatever X is. Whatever we drain off of 40% antifreeze, we're going to add 100%. So we're going to add X quarts of 100% antifreeze. How much antifreeze are we going to have in the end? 8, because the tank only holds 8. Got it? So we have 8, that's 40%. We're going to drain some off, which also represents 40%. Whatever we drain off, we're going to replace with 100% antifreeze so that we end up with 8 gallons of 60% antifreeze. We're trying to increase the ratio of antifreeze to water. All right, so multiplying 8 times 4, that's 3.2, right? Minus 0.40x plus 1.00x equals, is this 4.8? Is that right? Did that math correctly? All right. Let's combine. Let's subtract our 3.2 to move it to the other side. Combine this. That's 0.60x is 1.6. And divide 1.6 by 6. How much antifreeze? What was the question? How much fluid should be drained and replaced? That's X. X is drained and it's replaced. So 1.6 divided by 0.6 is 2 and 3 2/3. 2 and 2/3. 0.667. 0.6 is repeating, really. So that's 2 and 2/3 quarts. Got it? Make sense? All right, let's go to 2.4, number 51. 2.4, number 51. That is on page 117. Square root of 2x minus 5. Square root of 2x minus 5 equals 1 plus square root x minus 3. Okay, I like this format. We have isolated one radical. Everything else is on the other side. I'm going to square both sides. So that on the left, I'm left with 2x minus 5 because the square root of something squared is just what's under the radical. But on the right-hand side, I have to FOIL. So 1 times 1 is 1. And then 1 times square root of x plus 3, x minus 3 is just square root of x minus 3. X minus 3 times 1 is also square root of x minus 3. Square root of x minus 3 times square root of x minus 3 is just x minus 3.
So you can't like distribute a square root, right? Or you can't like individually square 1 and x minus 3.
Right. So I end up with 2x minus 5 equals negative 2 plus x. So I combined everything that wasn't under a radical. And then I have 2 of these. Plus 2 square root of x minus 3. I have 2 like radicals. I'm going to move everything except the radical to the other side. So I'm going to add 2. And I'll subtract x. And I'm left with x minus 3, isn't that strange, equals 2 square root of x minus 3. Got it? So now I'm going to divide by 2 because I don't want the 2 there. So I'm left with square root x minus 3 equals x minus 3 over 2. Now I'm going to square both sides. On the right-hand side, I'm just left with x minus 3. But look, this is the same thing on the left-hand side as x minus 3 squared over 2 squared. All right? So that's x minus 3 equals, we're going to square that. I'm going to square it without writing it. X squared minus 6x plus 9. That's x minus 3 times x minus 3. Got it? Yes?
The step before that, could you divide both sides by x minus 3?
Say that again?
Divide both sides by x minus 3.
Before I square?
From your squared number, instead of putting it into the quadratic.
I could.
I don't think it works for all of them.
I could. I hesitate doing that. I'm not sure why, because I'm thinking trig actually. I would never do that in trig. But that's a good thought. Let's figure out if it would work in the end. Over 4. I'm going to multiply everything by 4 to get rid of the denominator. So that's 4x squared minus 24x.
Multiplying that before, doesn't it just take the denominator?
Yes, thank you. Nothing happens on the left-hand side. Do this, Paula. There we go. So it's x squared minus 6x plus 9 equals 4x minus 12. Now I would set it equal to 0. So I'm going to subtract 4x and add 12. So that I have x squared minus 10x plus 21. That's factorable. What does that look like factored? x minus 7 times x minus 3. So x is 7 and 3. Maybe we have to work it. So does 7 work? That's 14 minus 5, which is 9. So that's 3. 1 plus 2 is 3. So 7 works. Does 3 work? That's 1 equals 1. They both work.
It's a lot of work and so easy to like make a mistake.
It's a lot of work. Yes, it is.
How many questions are on the test?
I'll tell you in a minute. Because I want to say 20, but I have a test with me, so I can tell you exactly. All right, now let's go to 2.5. I'm going to spray the board real quick. 2.5. It's a little hard to erase. What page are we on for 2.5?
124.
124. All right, everybody on page 124. It's not going to necessarily be an easy test, but it's doable.
How long do you think it's going to take me? Because I'm taking it after.
I think it'll take you an hour. All right, page 124.
Is it the same length as our old text?
Typically, they are not, but this first one is longer than normal. All right, so we're on 2.5, number 35. That's where we're going to start. 2.5, 35. I'm trying to get there on my iPad. I'm almost there. Okay, 35. Let's look at the instructions. Solve the inequality, express it in interval notation. Okay, because we have x everywhere, we have to see this as two separate inequalities. The 2 on the left and the 2 on the right. So the middle one goes with both of them. So this is a conjunction. It's that and that. All right, I'm going to move x here for this one, and I'm going to move x here for that one so that I have the x's next to each other. All right, so I'm going to add x and subtract 1. So I'm left with 3x less than 2, x less than 2/3. We did not change the sign because we didn't divide or multiply by a negative number.
Okay, so if you're subtracting by negative, we still keep it.
Oh, correct. Keep it. All right, I'm going to move my x here. So I'm going to subtract 3x. And I'm going to subtract 1. So I'm left with negative x less than or equal to negative 5. Now, I'm going to multiply by negative. This is going to be a disjunction. All right, so this is a disjunction. X has to be less than 2/3.
Wait, can you please?
Yes. That is not what your textbook says.
Wait, when you divided by 3, why didn't you move the sign?
I subtracted.
No, I meant on the other one. When you divided by 3.
Because it's a positive number.
Oh, okay.
book says something totally different. Let's see if I wrote it down wrong. X minus 4. No, I think your book answer's wrong.
I don't like that.
Yeah.
Okay, that's very close.
Yeah, I think your your answer. So it would go from negative infinity to 2/3, and from 5, unless it said something weird in the instructions. Yeah, there's nothing weird in the instructions. 5 to infinity. It only gave this solution. Looks like in the answer key, it didn't give this first solution.
So you wouldn't have to do like the graph thing, number line.
You do only interval notation.
He actually is.
Only interval notation.
For the test? we
For
do-
the test, only interval notation. All right, number 49. Okay, 49 says solve the inequality, find exact solutions when you can. Let's see, 49. So it's on that same page. All right, 49. X cubed minus 2x squared minus 3x less than 0. All right? Less than 0 is below the x axis. All right? Axis, that's singular actually. Okay, so because we don't factor cubics, that's not factorable. I don't think it has nice even numbers.
Can we factor an x? We can't factor an x out.
Oh, wait, we can factor an x out. X squared minus 2x minus 3 less than 0. Okay, now we can factor this. Okay, so what are our x-intercepts?
X is less than
0,
3.
3. I'm gonna write -1 here. Okay. Because this is a cubic, -1 is gonna be an x-intercept, 0 and 3. And because the lead coefficient is positive, it's gonna start in this quadrant. So it goes here, somewhere, back down, and there. So we want every part below the x-axis. So below the x-axis is negative, it's not equal to negative infinity to -1 and 0 to 3. You could graph this in your calculator and see it visually.
Wait, why?
You're gonna have to know this, yes.
Why'd you put a -1?
Well, because I wanted it in numerical
Wait,
order.
So we go to y equals.
Y equals, you could graph the original one. You're gonna see something like this, yes.
Why do you like write it that way? Or what are you actually looking
What
for?
is below 0
Okay.
is below the x-axis. Yes, Josiah?
On the problem before,
Yes, 48?
yeah, it had the,
Greater than. So
Yeah.
it's everything above the x-axis.
the reason they only had the one error in the back was because I tried to plug in 0, and if you get, you end up getting 3 is less than 1 on one side of it.
Oh, did I worked 48 instead of 49. Did I? No.
No.
Are they the same? No, they're so close.
This one was, or this.
47.
Yeah, 47.
Okay.
So it ends up,
So 47,
I think it was
Studies for
no, it was 35. You did it.
35? We did 35 a minute ago.
So it couldn't have been between negative infinity and 2/3 because if you
It
put
did. Yes. I think your book's wrong.
Well, I plugged in 0 and it said it gives you 3 is less than 1.
Oh, that's why you're not supposed to have to check those. It's weird that it's a disjunction. That is a very strange question. I'm not going to ask something like that.
Wait, so
It
for-
should have been a conjunction. No, I don't. I would take your answer exactly as I wrote it.
But for 49, we'd have to graph that in our calculator. And
You
then
could.
look at it. And we'd say, since it goes down to infinity, it stops at 1.
-1, yeah.
And then it also goes from 0 to 3.
0 to 3 is below the x-axis. Less than, below the x-axis. Greater than is above the x-axis. All right, now we're going to do problem 51 on the next page. Well, actually, it's just your page over. Okay, how are we going to factor 51? The u. Again, we're below the x-axis. It's a 4th degree. Our lead coefficient is positive. It's going to look like this. Okay? So this is u squared minus 5u plus 4. What are our factors?
4
-4, -1. U minus 4, u minus 1. Now we're going to go back to x squared. X squared minus 4. And we're going to set it equal to 0 to solve. X squared minus 1 equals 0. I didn't need the parentheses here. So x squared equals 4x is plus and minus 2. X squared equals 1. X is plus and minus 1. So if I draw this,
So I graphed it in my calculator.
well, that should be -2, -1, 1, and 2. So it's only below the x-axis between -2 to 1 and 1 to 2.
See, like, I can't see.
I know.
Is it okay if I
It's a
say
really
it?
bad, yes. Or you could sit there. Either one. That's a great. The
Can you
most
also see if I sit right here?
Yeah.
Okay, I'll sit to the side.
I agree.
To the
That's
side.
okay.
Wait. It's
And then we only
-2
get
to 1 or -2 to -1?
Wait,
Negative.
Alright.
and it's less than, so you only do it to the
What's below?
Do you have to draw it to figure out what's below, or you just take?
I do. I like a visual.
But like,
I like a visual. You could graph it in your calculator. Yes. Okay, in your calculator, you could just put this in y1.
You have to do the
So just x.
X to the 4th minus 5x squared plus 4. That's correct. In y1, look at it. You've already got your x-intercept, so you don't have to do second trace. I think this is faster than second trace.
Would
0.
just the calculator be accepted on the test, or would you?
Unless I tell you to factor it. Yes. Unless I give you instructions to the contrary. All right, 59. All right, tell me what I need to think about for 59.
the bottom should not equal.
The bottom,
Not equal zero.
the denominator cannot equal 0. But I'm looking for below the x-axis. I'm going to factor both the numerator and the denominator, because that will tell me probably. Okay, what's the numerator factored? x plus 2x minus 1.
Yes.
And the denominator factors.
Wait.
X.
Factors of
Minus
negative
3,
2,
x plus
such that we add them and they're positive 1.
X plus.
Multiply equal negative 2. It does. Added equals positive 1, and it does.
Oh, I was thinking of it. Sorry.
Multiplied equals negative 3. Added equals negative 2. It's going to be negative 3 and positive 1. Right? So, there are no zeros in the numerator that make the denominator 0. So, you're just looking at the zeros of the numerator.
Wait, can you repeat that?
There are no zeros of the numerator that are also zeros of the denominator.
Then it's equal, like the answers are the same.
Correct.
They
What would
both
that- if they were the same, what would that like entail?
undefined
It will be undefined.
But how?
because the denominator.
Denominator cannot equal 0.
Wait. Even though 1 is. Oh, it would have to be negative. Wait. So what if it was x plus 1 on the top and bottom?
So you know, huh?
What if it was you would just cancel it?
What
they
if
would
what?
cancel- If it was x plus 1 on the top and bottom.
Yes, you cancel them.
So then. Okay.
So you look at your zeros of the numerator, and then y'all are going to have to graph this. Your zeros of the denominator, because they're going to be undefined. All right, so graph the original in y1. We want below the x-axis. So that's what I want to see.
Okay, wait. If it was equal to 0, would we just say negative 2, 1? Because we know it's not.
Well, something still happens at these because it's part of the equation.
Why do we have to graph it?
To see what portion is below. Something happens at these numbers. So we're looking below. Yes.
So we put the whole thing in.
Parentheses divided by the numerator. So x squared plus x. It's going to look weird, but you only want your window to be this for x. So I'm probably going to go negative 5 to positive 5 for x.
What about from y?
I want to see close to the
So
y
negative 1 and
to
1.
the x-axis. Yeah. Yes,
And so
ma'am.
you just put the denominator in?
Divided by that. So that divided by that in parentheses. Yes, Caroline?
What was the window again?
That's for x. It is undefined, but we need to see what portion of this ratio is below the x-axis. Okay, well, I'm above. So at negative 2, I go down. I go down from negative 2 to 1. All right, so this is what happens.
Oh.
There's negative 2. So it goes down. It cannot equal negative 1. So what happens is it comes back up here. It stops going down. It comes back up here, and it goes down.
Mine looks like this.
It does it again.
Yeah. Oh, wait, mine crosses at 2.
Do you have a
Negative 2.
Well, what's your window?
It's above.
Oh, it never crosses.
It's not ever going to cross
So why
again.
is mine different than yours? Oh wait, because is my x?
You didn't do an x squared for the first one. Okay, so where's it below the x-axis? It's between negative 2 and negative 1, and from from 1 to 3. Because at 3, it's undefined. 61 is just like it. Similar to it. All right, let's work 61.
Wait, it doesn't, mine doesn't cross at -1.
Correct, it doesn't, but
So
it
why is it-
cannot equal -1 because there's an asymptote. So what happens at -1 is it goes here and then it jumps to positive. You see where it jumps to positive?
Yeah.
And then it comes back down. Here's where it goes below the x-axis again. It cannot go at 3. It stops.
Okay, wait. So
Just don't get
what do we do with the knowledge that it intersects at -2? Is that just for the like? Isn't that what we got already with the x equals up there?
Yes. And we look at this because this is where it is undefined. So I wanted to know what happens at -2 between -2 and the next one is -1. So what happens there? And then what happens between 1 to 3? It cannot equal 3. And I'm looking below the x-axis. So at -2, this is such a rough graph. At -2 is where it's below the x-axis. It has to do something different at -1 because that's undefined. It has to stop. There's no graph at -1. So that's always going to be your endpoint. And then on just to the right of -1, we see it in the positive, that's above the x-axis. We don't see it go below the x-axis to 1. It has to stop at 3 because then it's undefined.
Because that's from the denominator.
Is that-
Is equal to 0.
Cannot equal that.
So if we find the zeros and we see that like the denominator it doesn't equal 0, then do we have to graph it? Because what is the graph going to show?
It tells me where is it above or below. Like, what if this would have been greater than 0? If this would have been greater than 0, then we would have been -infinity to -2. And then we would have been -1 to 1. And then it's above at 3. And then it would have been 3 to infinity. Somebody saw it above 3 in your window. So you have to graph it to see whether or not it's above or below. Greater than is above, less than is below. Yes.
So the x-intercepts that we find by
That's where it moves above or below. Yes.
So we
The
just
x-intercepts for the numerator. That's where it moves above or below. Correct. That's where it's going to cross the x-axis. That's what you want to see. Does it go above or below the x-axis at that point? And it just depends. Are you looking for greater than or less than? Okay, we can work 61. There's nothing like this on your test, I do not believe. It will be later. All right, but look at 61. It's x minus 2 over x minus 1 less than 1. You always want it set equal to 0. So move the 1 over. Then you want a common denominator. And you're going to remember when we move the negative up, it's distributed to both terms in the numerator. So it's x minus 2 minus x plus 1 over x minus 1 less than 0. Our x's eliminate. It's negative 1 over x minus 1 less than 0. Okay, y'all, that has to look very strange. graph that in your graphing calculator. Something has to happen at -1 or at 1. Something has to happen. X minus 1 less than, okay. So something only happens at 1. You see there's no x-intercepts?
Wait. What did you graph?
I graphed that.
Yeah, me too, but I only got one line. Oh, is it because my window is different?
What's your window? That's what I have. Go look at your graph again. Y equals. Use parentheses between x here. Because your calculator's doing -1 divided by x, and then it's subtracting 1. Okay, so here's what you should have. Something like this. Actually, it goes more like this. And then something like this. Alright? It cannot equal 1. At 1, there's what's called an asymptote. So it's only below the x-axis from 1 to infinity. So that's your solution. From 1 to infinity.